on the second law of Newton, second law of motion. Now another problem example we can calculate, we can how to apply this second law of motion on different problems. Suppose a particle is moving. This is x direction, this is y direction, something. And suppose that this is in the time t. In the time t, this is not this x direction, this is the time axis. In the time t, we are calculating, we are having a particle, but this particle is moving in the y direction and in the time ultimately, because everything runs in time, and it follows a path like this. See, it follows a path, and in yt coordinate axis it follows a path like this, and the motion of the particle, this particle is given like this: y is equal to ut plus 1/2 of gt squared. But g is the gravity, keep that in mind, we will ultimately know it. Acceleration due to gravity, rather acceleration due to gravity. Okay, so we have to calculate here what will be the force acting on it. What will be the force acting on the particle? Fine. So how to calculate it? We know from the second law of motion we have force is equal to mass into acceleration. Okay, and we have considered that the mass of the object is m, so this is known. Now we have to calculate acceleration again. Fine, but we are only given the y term. Y is the distance covered at any instant of time, okay, by the body. So how we can calculate the acceleration? We know that acceleration is the double differential of d2 of the distance covered with respect to time. This is the distance, and here in case of this problem we are indicating distance with by the term y. Okay, so acceleration here will be double differentiation of the distance covered with respect to time. So we will differentiate this, differentiating with respect to time of what? Y. So we'll get dy by dt, d by dt of ut, because y is equal to this, it is given here, ut plus 1/2 of gt squared. So upon calculating this, we'll get this, u will be outside, so we'll get u plus upon, I hope that you are getting this differentiation and integration. You have already seen these terms, like I will differentiate this very term, d by dt of 1 by 2 gt square. 1/2 of is constant, keep it outside. G is also constant, keep it outside. So we have to differentiate d by dt of d squared. So that will be equal to 1 by 2g. Differentiation of anything, differentiation of x to the power n is given by n x raised power n minus 1. Keep that in mind. So here is n is equal to 2, so we'll get 2 times. Furthermore, you can solve it yourself. I'm sorry for that, there was some technical issue here, so that's why I couldn't record that very portion of this problem. So I have provided you the answer of this very problem here. It is solved, and after that you can see on this problem yourself to get an idea that at the end of the day, for this problem, if a particle's motion is given by the equation like this, so at the end of the day it means that the particle is under the effect of the gravity, and that equation is given by that very acceleration is given and solved by this problem, and ultimately we get acceleration is equal to the g, that is the acceleration due to gravity. Okay, and from that we can calculate, from second law of Newton we can calculate the mass, this force applied on to this very particle, which is exhibiting the force, which is exhibiting the motion from this very equation which is given there. So sorry for that, sorry for the inconvenience. You have to solve it yourself, and a kind of intuition I have given you. So kindly solve for yourself this by looking onto this problem which I solved myself now. So sorry for that, there was a technical issue. So kindly look into it and try to understand how this equation is brought into existence, how this acceleration is equal to the acceleration due to gravity. So hope you get it very soon. If not, please feel free to comment in the comment section. I will explain it further maybe in the next lecture. If you feel some problem there, please comment in the comment section. I will see you in the next.